This is the Calculus Pre-Lecture Series. I'm Caitlin Murphy, and this podcast is on series. Series is another name for a sum of numbers, and you can construct a series by adding the terms of a sequence. So let's consider the sequence given by a sub n equals n, for n equals 1, 2, 3, and so on. We can expand this a little bit by writing a sub n equals 1, 2, 3, 4, 5, so on and so forth. So for series, we use something called sigma notation. It looks like this. It's a Greek letter, a capital sigma, and we index it with a starting point and an end point. For instance, we could do the sum from n equals 1 to 5 of n. And that would be, in the first iteration, n would be 1, so we'll do 1, and then we're just going to add each iteration. So in the next iteration, n would be 2. We're going to keep increasing n every iteration until we get to the ending point, which we said would be 5. So the sum from n equals 1 to 5 of n would just be 1 plus 2 plus 3 plus 4 plus 5, which that sum is just 15. Okay, so that's a finite series. We also, in Calc 2, are going to use a lot of infinite series, where we study the sum of an infinite number of terms, and that might look like the sum from n equals 1 to infinity of n. And that's 1 plus 2 plus 3 plus 4 plus 5, but it doesn't stop. It just keeps going on forever. Okay? Unfortunately, we can't sum an infinite number of terms the same way we can a finite number of terms, so we'll have to study them a little bit differently than finite series. So let's consider the sum from I equal 1 to infinity of 1 over 2 to the i's. So these are powers of 1/2. So we have 1/2 plus 1/4 plus 1/8 plus 1/16, and it's just going to keep getting smaller and smaller. And we're going to try to decide if this sum converges to a number. And we're going to use this 1 by 1 square to help us decide. So say this is a 1 by 1 square. Okay, so let's add each of these terms to our square. So first we'll add 1/2. So if we add 1/2 of our square, that looks like this. We added 1/2 of the square. Next we'll add 1/4 to the square, and we can add a fourth by adding half of what's left. So here is a fourth of the square. Then we'll add 1/8, which is just, again, 1/2 of what's left of our square. 1/16 similarly is going to be 1/2 of what's left. So on and so forth, and you can see that as we continue this process and keep adding powers 1/2, we're just keep going to be basically backing ourselves into this corner. So it's never going to be more than 1, but it's going to be, in a way, getting arbitrarily or infinitely close to 1. So we would say that this sum converges to 1. It can be shown that some series don't converge to a number. For instance, the sum 1 over n from n equals 1 to infinity does not equal a number, and we say that that sum goes to infinity. We say that this type of series diverges. We call it the harmonic series. But ours, since we decided that it sums to 1, converges. And we're going to be using these two terms, converge and diverge, a lot to describe the patterns of our series.